Hi, my name is Brian Meacham. This presentation is part of the Reimagining the ICC Performance Code series. And in this presentation, I want to walk through some of the outcomes from the first survey that we had run on perceptions of performance-based codes and design. Previously, we had uploaded a PDF of the main outcomes, but subsequently we've gone in to the data in a little bit more detail and looked at differences or similarities between US and non-US responses, and a look at also some differences within the respondents from the US group. So as has been noted before in the uploads and in the documents, the aim of the survey was to understand people's perceptions about performance-based codes or regulations and about performance-based design. There's no right or wrong answer. It's, what do you think about the state of practice and about these documents in general? While going through the survey, there were, of course, some concerns, a few comments about the lack of definitions and that maybe people didn't understand everything in the same way. But to a certain extent, that was intentional, trying to understand what people think of performance from their own perspective. And so that, creates some uncertainty in the data outcome, but I think that's to be expected and anticipated. In total, there were 194 responses, but only somewhere around 130 to 135 were complete enough to be used in the whole analysis. This is because some people chose only to answer a few questions and then stop the survey for whatever reasons. And so for many of the survey responses, you'll see n equals some number, and that'll be the number of respondents in each category. For the previous overview summary PDF that is posted, this is provided for all the answers. For some of the comparisons, however, it's a little less appropriate and more difficult to do because we're looking at particular aspects. And so here I want to present the data and talk a little bit about, maybe commonalities and differences between the US and other countries, and how different groups within the US look at the performance issue based on these responses. And this is one thing I want to be very clear about. This is just an indication of what the respondents think. There's not a large enough sample size to say this is what the industry thinks or any of the engineering disciplines or architecture or any of the other groups think. So as you listen to this and as you look at this, don't assume that it's broadly representative of the group in general. It really only is a snapshot of what the respondents think and the perspective as they represented themselves in the survey. So there are 5 sections overall. In the first section, we wanted to collect some information about where they're located, the sector and job that they're working in, education and experience, to see if that had, impact at all on how the people answered. We collected no specific information about people, so we don't have names, email addresses, or the rest. It was all anonymous from that perspective, and we rely on those who responded to provide, their perceptions in a free way. So if we look at country, out of the 194 total respondents, a wide majority was the US, 137. This is a result of us marketing in that way, that we want to hear what the US respondents have to think, but also compare with other countries. There were a few other countries that had quite a few respondents, England and Canada in particular, but Slovenia as well. And, it's always nice to kind of see how the US group, which we're focused on, compares to the rest of the world. And again, it's a small sample size. So when I say rest of the world, I mean those people who have responded. It would be nice to have, a much more robust data set, several hundred responses, but I think, at least being over 100 is enough to have some sense that there's if we can see a trend, the trend might be representative of more than just the people that have responded. If we look at the different breakdown of groups involved, there was quite a few, both in the non-US and US, who were in the consulting sector. There were also quite a few in building code compliance and quite a few in architecture, at least in the US, and a lot in other engineering disciplines. So as you might get from looking at some of the high percentages, those are ultimately where we'll focus kind of intra-US comparisons where there will be enough data. Again, when we set this up, we were hoping for, quite a bit of response from all the different sectors. And, it's good that we have some input, but we can't say a whole lot about, what any of those sectors or disciplines particularly think. We look at this slide again, it may be a little bit difficult to read, but we're provided people with a range of responses in terms of their primary work function, sustainability consultant, structural engineer, fire protection engineer, architect, and so forth. Those groups in which we had the highest response rates for the US were structural engineer, fire protection engineer, building code official, and architect. And so as we go through the data, those would be the perspectives that dominate. And for a few questions, we'll show you how the responses from those groups are similar or different. If we look internationally, fire protection engineers represented the largest group, and some of this, is likely due to my background in fire protection engineering. So me going out through LinkedIn and other mechanisms would attract more attention from the fire protection community. We asked about education just to kind of understand, that demographic. High percentage are college educated, many with master's degree, both in the US and internationally. And I think that reflects a lot on the engineering professions that are represented. If we look at licenses and registration, high degree or high number of respondents had professional engineers license or equivalent, registered architect's license or equivalent, or if you look down in this bottom grouping, certified plans examiner, certified building or fire official type certifications. And again, this is helpful to understand the perspective that people are coming from, how many had some type of professional licensure or certification as perhaps compared to others who didn't. And if we look at overall, most people that responded did have some type of certification, some, had certifications that weren't listed, others worked in areas or parts of the world where certification was not required. We also wanted to see what the experience level was of the people who responded. And it's pretty interesting to me that if we look in the US particular, almost 50% of the respondents had at least 30 years of experience. And so to a large extent, we're not talking about people new to the profession who may have a particular bias towards use of engineering tools, but maybe have seen more practice and have understood and experienced performance design or approval of designs and designs in general, which is good because it's coming from a place of of experience, as well as in addition to just recent learning. And I think in the non-US respondents, it was a little bit younger group that responded, but nonetheless, we'll focus a lot on the US in later parts of the analysis. Section 2 was where we then started to get into, well, what do you think about performance-based codes and performance-based design? And here we wanted to look at what type of regulatory system the respondents worked in, so performance-based or prescriptive-based, and how they perceive either system to operate that they worked in, as well as how they perceive performance-based, even if they were not working in a performance-based system. And so here you can see that for a large majority, 85% of the US view themselves working in a prescriptive type environment. And it's interesting here that even 15% thought they worked in performance. And so, it was defined mostly that a prescriptive system is characterized as having a large degree of specific requirements that have to be achieved, some of which may be reflected in performance criteria, as compared to a performance-based system in which the goals, objectives, and functions are stated. So what do you expect the building to achieve without specifying specifically how to achieve those? And so my bias, my view is that the US system is largely prescriptive, even though there are some performance measures in the code and performance requirements for demonstrating how you can comply with the code. And a significant majority of the respondents view it in the same way. It's a bit interesting that it's about 50-50 in respondents from outside of the US, which means that we had more percentage-wise respondents of people working in a performance system, but still quite a few working under a prescriptive type environment. So then we wanted to find out, in general, regardless of the type of system you're working in, how well do you think the system is working with regard to facilitating well-performing buildings? And I think in both the US and non-US, the majority thinks it's working well or very well, but in the US, it's really 60%. It's not that much over 50-50. And there's quite a few, 32%, and if we include the poor, 40% that don't think the system works very well for delivering well-performing buildings. And so that's interesting, a little bit perhaps from the perspective of, if the prescriptive system is not delivering the performance expectations very well, then there's a sense perhaps that something should change. What I found really interesting is, a full third of the people outside of the US thought their system was working very poorly. We don't have a huge data set there, but that is something that would be really interesting to explore in detail in terms of, are those people who are in a performance system or a prescriptive system, and really trying to understand. Hopefully we'll be able to look at that in more detail as we go on, but the data are small, so it would be tough to say too much about it. So then the question is, regardless of the system you're in, do you support the concept of a performance-based structure for building codes and the building code regulatory system? And here we see, if we look at the strongly agree and agree, significant support in both the US and from non-US participants. We're in the 70 to 80% range, which is really good. So even though most of the US, for example, respondents view themselves as working in a prescriptive environment, they support the concept of a performance-based structure. And I think that's key, that if we're supporting the concept and want to try to get there, then that'll be important to understand really what's necessary to get to that point where people feel comfortable and confident in the system. In this next question, we wanted to know if you have a performance code that's either in use in your country or available for adoption. And so the reason for writing it that way is that in the US, for example, we have the ICC performance code, which is available for adoption, but it's not used very much. So we wanted to be able to capture perceptions of that code, which is available for adoption, as well as the performance codes that are actually being used. And what we see here when we want to know if those codes and the system that supports them, which includes methods of verification, standards, registration and licensure, and all the rest, can it be used with a high degree of confidence and comfort? And here, overwhelmingly, in both the US and internationally, the answer is no. People do not think that, either the current system that they're using or that could be used is appropriate or has all of the features or attributes that really need to be there to make the system work well. And here again, we're over 50%, into the nearly 60% range. And so, that's, that says that while in the US, the respondents think performance could work, the current system and approach doesn't work very well. And internationally, one could say that for those people who responded, and many of them in a performance environment, they don't think the system is working as well as it could. So this means that there's room for development and advancement, and this is one of the things that we wanted to find out with this work. The next question then was looking at, regardless of how well you think the system, performance-based code or regulation that is in use or is available to be used works as it is currently envisioned, do you think it's possible to actually develop and implement a performance-based code and system that could work at a level of comfort and confidence that you would be accepting of? And here again, we see people strongly agreeing that they think that could happen. So, again, we're talking only about respondents. We're not talking about this being applicable to all, the stakeholders in the US or all stakeholders in other country. But the trend here is from the respondents that, there's a strong sense that performance can be helpful in delivering better buildings. It can be helpful in actually working if well constructed and implemented, but the current system we have now just isn't quite there yet. So I think that was important findings out of this initial survey. There's going to be quite a few slides like this, which I know will be very difficult to read. You might be able to download the PDF version of the presentation and read it in more detail. But basically what we're doing in these types of slides is we're asking a number of questions about what people think about different attributes of the system. And we're representing what respondents from the US think versus respondents from outside of the US. And in this question, the idea was for different attributes of the building regulatory system, which do you think is or is most likely true? And some of this, for example, we'll just take the top one. It is easier to make changes in the building in the future. And so in the US, just about, let's say 35% think it's easier to make changes to or building designed under prescription in the future. A few, maybe 20% think performance, and about 55% think that it's about the same in either. In the non-US, you see a little bit different in that the people who responded think that it's easier to make changes to the building in the future into a performance if the building was designed under a performance regulatory system. And of course, there's differences a little bit in how people would interpret each of these, and so none of these can be said as being 100% representative of anything other than the respondents' views. However, there are a few things that are particularly important, or what I would say even consistent internationally. I think there's a view right now in the current system, for example, the risk of missing something important in the review of building designs is higher in a performance-based system than in a prescriptive. And very much tied to that, the importance of peer review or independent review is much higher in a performance system than in a prescriptive system. And that type of a trend carries through to qualifications and competency of practitioners, of review authorities, and the need to have appropriate insurance. And that's pretty consistent in the US and around the world. I think it's also interesting to see that other areas where performance seem to have a higher degree of importance, or is most likely true, is the overall flexibility in design and construction is higher, innovation occurs more often, and the ability to innovate is higher. And so generally, I think there's this two sides of the coin here. Everybody that responded tends to agree there's more flexibility and ability to innovate in a performance system, but there's also a higher risk of missing something in the design and review process. So qualifications, competency, and peer review are really important. For me, these are not necessarily new findings. These are consistent with what we've been hearing for a number of years around the world. In this next question, we've asked people to indicate the relative importance of different attributes. So the attributes are listed here: existence of recognized independent third party, qualifications and competency of those involved in review and approval, confidence in tools and methods of design, and so forth. And again, I won't go through all of these in detail, but you can see that all of the attributes that were listed actually came out as being pretty important to be considered in performance-based regulatory structure and then performance-based design. So this is something that I think we will want to look for and look at in more detail as we go forward. And if we just highlight those that have the highest importance, it was qualifications of the people involved on the design and the review side, and the confidence in the tools that are being used. So I think this is already becoming a pretty important theme. Section 3, then we wanted to get a little bit of a sense of what people know and think about the structure or the framework of the performance-based codes and its major components. And so I won't read this all in detail. Again, downloading the PDF will be helpful, but most performance-based building codes have a common structure, and that you start at the top with a high-level policy goal or societal goal that the regulations should achieve. And those are in areas such as health, safety, and welfare, sustainability, and resilience. And in some countries, those goals are in the enabling legislation, and other countries, they might be in the building code itself. The codes often start with objective statements which are intended to provide clear statements or descriptions of the objectives to be met in achieving the policy level goals. And so this could be thought of, in the IBC in the US, for example, as an intent statement. It's intended that, Chapter 10 will provide safe egress requirements for safe egress from people and buildings. And so it's really typically a general statement of what you're trying to achieve in the building. The next level down is functional statements, and those are often providing qualitative requirements for buildings or specific elements of buildings that give you more detail in terms of how building objectives might be met. The next level is performance requirements, which should provide actual requirements in terms of performance criteria or expanded functional descriptions that will be the basis for verifying compliance or verifying performance against the objectives and functional statements. Then most systems have two kind of compliance pathways. One is a set of acceptable solutions, which are often deemed to satisfy the code provisions. And in some countries, these would be, for example, very similar to saying the IBC would be one means of complying with the requirements in the ICC PC, which is how it's set up in the current system in the US. In England, it would be the same way. The approved documents would be one way of meeting the performance as outlined, or the functions as outlined in the building regulations. The other mechanism is more analytical means of verification, which are analytical, computational, and test methods that provide data that can be used to demonstrate that the performance objectives and requirements have been achieved through testing, through modeling, and through other types of analysis. So there's another presentation that I put together if you want more information about this, that overviews a little bit of history of the development of performance-based building codes in general, what the general structure is, and maybe some challenges and trends going forward in the future. But we laid this out and gave this information to the respondents as a way to kind of benchmark when we're talking about the current structure and answering the next questions. What do we mean? And so the first question we wanted to ask was, if a building regulatory system which is in use is performance-based, what percentage of buildings do you think are designed and constructed using one of three different approaches? Largely prescriptive documents, which could be a prescriptive deemed to satisfy approach, some type of standardized engineering or verification method, which might be a very rigorous step-by-step process with methodologies that you would use to demonstrate the performance compliance, or broader performance-based approaches, which in some countries might be called a first principles approach, in which any appropriate engineering data, tools, and methods you bring to the project should be deemed appropriate to be used. And I think, what we can see here is that even in a performance system, whether you're in the US or outside of the US, people thought most buildings would be designed using the prescriptive documents, and that, very few designs. Here we see kind of about 60% of the people thought that less than 20% would be designed using performance in the US, and it was pretty similar. Almost 50% thought it was, less than 20% using performance design internationally. And so this has been found in a number of different surveys and analysis that it's really important to have these prescriptive, more rigorous, deemed to satisfy approaches, because they're really used much more often in compliance and verification of performance for buildings, because most buildings are relatively straightforward and don't need to be performance-based design. And this is true inside or outside of the US. And so that deemed to satisfy pathway is very important. And the respondents saw that as well. We asked the same question in terms of compliance with prescriptive-based building code, which percentage of documents are used. And again, it's no surprise here that mostly prescriptive types of compliance documents are used in performance. And here larger percentages of respondents thought that less than 20% of the designs in the case of the US, that would be designs using the alternative methods and materials clause, would use performance-based approaches. And so this kind of balance of less than 20% of the designs are going to be fully performance-based is pretty universal, at least again from the respondents' views, but also as supported in other documentation and surveys that have been done. And it really focuses on unique buildings. And so if you're only going to focus on unique buildings or high hazard buildings or buildings that have other issues that make it really hard to fit completely a prescriptive based approach, those are going to be somewhat small in number. And if we think back to some of the other answers, that means you want to have a higher level of rigor and review. So there's a very good correlation, I think, from the data and from previous studies that say nobody really expects performance to be used all the time, because it's not just practical. When it is used, there's typically a good reason, but it's not easy to do really good job on performance on the cheap. So therefore, make sure you have good guidance and make sure you have good review systems in place to make sure everything's done appropriately. So I think that was an important finding. Another question in this section was, does this framework that we have of top level goal, objective to be achieved, functional statement, performance requirement, and so forth, is it appropriate to be used going forward? Is it sufficiently comprehensive, and is it robust enough that we keep that basic structure and kind of fill in the gaps if we think there are gaps elsewhere in the system? And here, as we can see by the the green colors, that there's significant agreement that that structure is largely effective. People seem to understand it, and it lays out the issues, and there's not a great need from the respondents' perspective to go back and make any changes. So now we have another question that is looking at kind of perceptions between performance and prescriptive-based approach, in which people think outcomes are most likely to be true. And here, for example, again, I won't read them all, but the top one is the overall performance of a building designed to meet the code will be better performing. And here we see that it seems like the performance code route to get better performing buildings seems to be a good indicator. Another area that people tend to think there's more accurate or more likely to be true, not accurate, in a performance-based system, is that the stakeholders will recognize that there are multiple pathways to develop and demonstrate compliance as compared to the prescriptives. And so this is interesting, just from the perspective that, in the US, we have the alternate materials and methods clause, which allows anybody to undertake a design, yet it's still very largely perceived that it's better recognized in a performance system that one can undertake that approach. And I think that's a key issue to think about, that there's a perception there that the performance is based code just allows more opportunity to pursue performance-based solutions. And some of that could be biased by people's experience and not being able to undertake a performance design under the alternative methods and materials clause in the US, but the same type of outcome exists internationally as well. So I think there's some type of perception issue going on that's important. At the same time, I think it's also important to point out that respondents think that the criteria used to demonstrate compliance or performance and the means to demonstrate compliance with the regulatory requirements is much clearer in a prescriptive code than in a performance code. Here again, this is true in the US and internationally. And so, what this is telling me is that, the performance code, while people think the structure is helpful, it's not always clear how you demonstrate the performance. And while there may be many pathways to do it, it's not so clear, perhaps both to the designer and to the person reviewing and approving, whether the right ones have been picked. So those, outcomes say that, suggest that some work needs to be done in those areas. Question 19 was looking at what types of criteria or measures would be helpful to have in a performance-based system as a means to help determining appropriate performance and compliance. And these range from quantitative risk values all the way down to qualitative statements using terminology such as acceptable or appropriate or reasonable. And what we see, a bit surprising to me, that there was a lot of support for quantitative risk values in the US as well as internationally. And that's not something that's currently existing in most performance-based codes. There's been a lot of discussion about it over the years, but it hasn't really made it there. So the fact that the respondents think, globally that this is important means it might be something to look at going forward. Also, in general, people are looking for quantitative values that can be readily calculated and verified by agreed methods and can be measured by agreed methods. So what that's saying is that we want to understand how you're going to measure quantity X. If we agree on that, then how would you calculate or predict quantity X? And if we agree on those two components, then we're in pretty good shape. And I think that's pretty universal, trying to get at those issues. I think where some of this is difficult in the current system is that if you're taking a quantified value that can be measured, for example, a flame spread index, which gives you a comparison between A, B, and C, and which one is better than the other, but it doesn't correlate to an engineering method that you can calculate that, then you're missing a step, because you can measure one, but then how do you do a calculation or an engineering analysis to demonstrate equivalency or equivalent performance? And so there's some work that needs to be done, I think, to work in those areas, which seems to be reflected in the data here. And I think it's no surprise that the respondents largely agreed that having simply qualitative statements without any quantitative criteria is not particularly helpful or desirable. The next question was asking different approaches to thinking about how you might characterize the building occupancy groups and so forth as being indicators for the level of performance you want the building to achieve. And that ranges from specifying tolerable levels of building performance for the various threats and hazards, to providing quantified values of the measures, all the way down to having only occupancy or risk groups, but with no, or use groups with no reference to risk or vulnerability. And I think, it's pretty clear that no respondents, or very few respondents in the US or elsewhere, thought that having only occupancy or use groups with no reference to risk or vulnerability was important. And so that's also important conversely, which means being able to identify the risk and vulnerability to occupants based on the hazard or features of the building is important, and finding ways to quantify that seems to be very important. So those might be considerations going forward in design of the system in the future as well. And trying to drill down on that particular issue a little bit more and trying to understand if quantification is important, what types of quantified values would be important. This next question gave, a list of different values or metrics in terms of affordability, quality, carbon footprint, energy performance, moisture performance, safety in case of fire, safety in case of structural performance, and so forth. And largely one could say that almost all of these metrics are seen to be important, but the ones that are really important are safety from fire, safety from structural collapse, safety in the normal use of the building, and accessibility. And I guess of all of these, perhaps surprising to me is the accessibility and usability of the building. I think that that's ingrained, that it's very important. It's not so clear to me that we've really got all the performance metrics by which to measure that. And so these are all areas that, the data are suggesting that it's important, at least to those people who responded. This next question was aimed at trying to understand how documents developed by different actors in the system should be used, or would be required to be used in a performance-based system. And it was trying to get at, do you have to reference all the documents to have them be deemed acceptable or appropriate in the building regulatory system? And so the choices are: it must be referenced by the code to be acceptable, it's helpful to be referenced but not required, or it's not required to be referenced to be acceptable. And so I'm not sure this question was understood appropriately, because if we look at the answers, they suggest that it's required that those documents developed by the regulatory entity or a recognized standards development committee must be referenced in the building code to be acceptable. And maybe people understood, but I would be surprised, because my expectation would have been that if the document was developed by a recognized standards development organization, why does it have to be adopted into the regulation to be deemed acceptable? And if you look at the other end, documents developed by an insurance organization, people seem to find that as much more acceptable, that it's not required to be adopted into code or recognized by the code to be acceptable. And so this one, I'm less sure about what the trends are saying, and I think it's perhaps a little bit misunderstanding in the question, but certainly something to explore later. In the next section, respondents were asked how they perceive the capacity in different engineering disciplines and review capacity and so forth to be able to undertake and review performance-based design using current guidelines and tools and methods that would be available. So the first question in this group asked, do you think the expertise, capability, data tools, and methods in general are currently robust enough to support uh, performance-based design for all or most aspects of building design? And I think the data suggests it's about a 50-50 split here, but more towards the negative side. And that reflects concern that, overall, respondents don't think that we have all the data tools and methods that are really needed to develop the robust performance-based designs that, they thought are possible based on their answers early in the survey. So if we then, look at what the US and the non-US respondents think of, different design areas' ability to produce robust designs. And here we're going, a few exemplar ones: acoustical, lighting, fire protection, plumbing, mechanical, structural, so forth. We see internationally and nationally that mostly, you know, people think that have some degree of confidence, roughly 50-50, that, there's enough to be able to do pretty good design. And so there's not a lot of difference between international and the US. What is interesting is that of all the areas, it seems like fire protection engineering is viewed as an area that is, maybe problematic in being able to do good performance-based designs. And, the US perspective on that, it seems to be that, the fire protection engineering community has a bit of work to do. And so when we're looking at these data, you might recall from the beginning that we had data, from fire protection engineers, architects, structural engineers, and building officials that was enough to kind of look at in more detail. So, fire protection engineering, yeah, maybe questionable. Structural engineering, there seemed to be a lot of confidence. So then we wanted to look at, for these four groups for which we have more data, what do the four groups think? And again, architects, building officials, fire protection engineers, and structural engineers. I think in just looking at the colors, the most pessimistic people are structural engineers, and the most optimistic are architects. And in general, architects and building code officials, looked at the engineering disciplines and said, maybe they think they're in pretty good shape to be able to do performance-based design. But if you look at the engineers, they're much more pessimistic about it. And, just looking at the percentage of green compared to the percentage of orange and red. And, the biggest areas of concern, again, is fire protection engineering. But what's interesting here is the fire protection engineers are much more pessimistic about their capacity to undertake good performance-based designs than the building code officials are about, the ability of fire protection engineers, or about how the architects view fire protection engineers. So this is really interesting to see that, how a discipline views itself as compared to how related disciplines view it. And the structural and fire protection engineering, which in previous questions people thought was maybe had the most robust approaches, those engineering disciplines are saying about themselves that they don't think they're there yet. So the next question wanted to go kind of beyond, would those disciplines be in good position to do design? Is the adequacy of the design standards, guidance methods of verification appropriate? And we see, similar trends, mechanical, or it seems that structural engineers are viewed as being in pretty good shape. Fire protection, maybe not so much. Internationally, it's interesting that, there were no one that thought it was, really well developed. And I think this represents the view that, seems to be consistent throughout, that while people think design can be done well, we don't necessarily have all the tools and methods to do it. However, when we look at kind of the breakdown here, we see that, it's interesting that, architects, don't think they have, their act together, as it were, as much as structural engineers, fire engineers, and others. Fire protection engineers don't think they have their act together as compared with structural engineers. Structural engineers think they're okay, but they actually think fire protection engineers are better off. And building code officials thinks, it's kind of 50-50 for both. And that's really, again, similar to the other breakdown, that, the disciplines, at least through the respondents here, are more cautious about what their capabilities are and where their guidance is at, and think more needs to be done. And that's probably a good thing. And the question will be, how do we get more going forward? The next question, and we're getting to the end, is, what's the current capability to develop a robust performance-based design for different building performance objectives? And here it's, again, a representative list: emergency responders, safety, emergency egress, multi-hazard resilience, fire resilience, earthquake resilience, flood resilience, and so forth. And again, comparing kind of, in the big sense, US to non-US, it's pretty similar. I think there are some areas that stick out, like multi-hazard resilience and wildland fire resilience, that, almost nobody thinks is being done well. I was a little bit surprised that, we're pretty pessimistic about flood resilience, and pretty surprised that we don't think we're doing sustainability very well. So neither sustainability nor resilience seems to be, tackled very well based on the perspectives. And also, without looking at those big ones, if you look at, fire resilience and egress, that's kind of saying to me that there's this perception that, we can, do an A set, R set analysis to get somebody out much more robustly than we can look at fire performance of structure. Yet to do an A set, R set, you need to know how the structure is going to perform. So I think we have some inconsistency in how we view things working. And we can do this breakdown again by architect, building official, fire protection engineer, and structural engineer. And we see something similar to the past, the previous slides rather, that the fire protection engineers are concerned that they're not doing very well in fire resilience. Structural engineers think they're not doing so well in structural resilience. And somewhat surprising to me, the architects think they aren't doing so well in sustainability, but they seem to be think we're doing okay in terms of energy performance. And, I think the building officials think, when we're applying these methods, we're doing generally a reasonable job. The next question was looking at the importance of third-party or peer review for performance-based design. Green colors, again, are important. The orange and red, not so much. So I think the big takeaway here is, two things. There's a lot of consistency, but the importance is on safety. If you look at safety related issues, and and I include resilience in that, the need for importance is much higher than what people are even saying about sustainability, accessibility, or performance and use. And so some of that, of course, will be representative of the people who responded, but I think it's also historic that our building codes have been really focused on safety, and some of these other issues like sustainability, we're still trying to get a handle on in terms of how we deal with it. Getting to the end, a big question of how important is it to invest in education, training, qualifications, and competency for different actors, and a lot of support for investment for safety related areas and for the enforcement. So if you look at building code and fire officials, that's high, but also for engineers who are working on safety systems, fire protection, structural in particular, but mechanical as well. So the bottom line is investment in education, training, qualifications, and competency is important across the board, most important for safety related issues. The last section of the survey was on kind of a free response. We asked people to provide additional feedback on anything that either we asked about or didn't ask about. So I can't really deal with that here. Questions 29 and 30, though, there's a full set of responses to those questions in PDF files posted on the website. Some really interesting feedback there that I urge you to have a look at. So to give a quick snapshot summary, the responses are quite similar, whether you're inside or outside of the US, in terms of what's working and what's not, and whether performance could be done in a good way. What was interesting was only a little bit more than half, regardless of where they were, think the current system works well, whether it's performance or prescriptive, but more than 80% believe that a robust performance-based building code system can be developed and implemented. So in thinking about what it would take to get there, quantification of performance, strong linkages to methods of design, verification, and compliance are critically important issues, and work is needed in all disciplines on the design methods and verification methods that would be used in the systems going forward. In looking at, based on the respondents, how different groups viewed themselves, the engineers have a much more harsh view of their capabilities in delivering performance and the capacity of their tools and guides than architects and enforcement officials. And engineers want to see more development of standards and guides to help them in their job. I think the data suggests respondents think we're doing a poor job with sustainability and resilience, and that could be because they're relatively new objectives, but it means there should be more emphasis on those going forward. And then it's really important to invest in qualifications and competency and verification, and that peer review is something that seems to be a necessary and important part of a robust performance-based approach going forward. So with that, I want to thank everyone who took the time to complete Survey 1, providing their perspectives, and that this will be really interesting input as we go forward with this project and think about how we're going to be setting up roundtable discussions and workshops. I also want to extend my sincere appreciation to Hao Yu Chen for his help in helping me analyze the data, formatting the outcomes, and which allowed kind of more of a deep dive into what we've really learned. If you have any questions, you should feel free to contact me at performance@iccsafe.org, and keep looking at the website for additional information. Thank you very much.